Serverless computing is a cloud computing execution model where cloud providers automatically manage the infrastructure and server resources, allowing developers to focus solely on writing code and building applications. Serverless computing offers several advantages for developers and businesses alike. First and foremost, it brings lower costs to the table. With serverless, you only pay for the compute resources you actually use during the execution of your functions, eliminating the need to provision and pay for idle servers. Simplified scalability is another key benefit. As your application experiences varying levels of demand, serverless platforms automatically scale the number of function instances up or down, ensuring optimal performance without manual intervention. This dynamic scalability is a game changer, especially during traffic spikes. When it comes to backend code, serverless allows developers to focus solely on writing functions without the burden of managing servers. This leads to simplified backend code, making it easier to maintain and reducing the complexity of your infrastructure. Moreover, serverless accelerates time to production. With the infrastructure abstracted away, developers can deploy and iterate on their code more quickly, leading to improved time to market for new features and applications. Increased productivity is a natural outcome of these advantages. Developers can direct their efforts towards building and refining features instead of dealing with server management tasks. This streamlined development process boosts overall productivity. Last but not least, serverless brings improved security. Cloud providers handle many security aspects, ensuring that functions run in isolated environments and follow best practices for secure execution. This helps mitigate common security risks associated with traditional server setups. In summary, serverless computing is a transformative approach that brings lower costs, simplified scalability, streamlined backend code, faster time to production, increased productivity, and enhanced security to the forefront of application development. Here are examples of serverless services on AWS. AWS Lambda. Lambda is a serverless compute service that lets you run your code without provisioning or managing servers. Examples of use cases include event-driven functions, data processing, real-time file processing, and more. Amazon API Gateway. API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs. It allows you to create serverless RESTful APIs. Amazon S3, Simple Storage Service. S3 is an object storage service that offers industry-leading scalability, data availability, security, and performance. While it's not purely serverless, it's often used in a serverless architecture for static website hosting and storing files. Amazon DynamoDB. DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. It's commonly used in serverless architectures for storing and retrieving data. Amazon SNS, Simple Notification Service. SNS is a fully managed messaging service that enables distributed applications to communicate with each other. It's used for event-driven and decoupled architectures. Amazon SQS, Simple Queue Service. SQS is a fully managed message queuing service that enables decoupling of the components of a cloud application. It's often used in serverless applications for asynchronous communication between components. Amazon Step Functions. Step Functions is a serverless function orchestrator that makes it easy to sequence AWS Lambda functions and multiple AWS services into business-critical applications. Amazon Aurora Serverless. Aurora Serverless is an on-demand, auto-scaling configuration for Amazon Aurora, a relational database service. It automatically adjusts database capacity based on actual usage. These services are part of the AWS serverless ecosystem and enable developers to build scalable and cost-effective applications without the need to manage underlying infrastructure.